Today, we're going to continue talking about solving oblique triangles. That's using the law of cosines and the law of sines to solve triangles. Remember, the solving triangles game is I give you 3 pieces of information and you find the other 3 pieces of information about the triangle. 3 angles, 3 sides. We want to know all 6 things about a triangle. We have talked already about the law of cosines, which is a general Pythagorean theorem. And I just wrote down 2 instances of it because we just have to permute the letters to write it for B equals and for A equals. And similarly, we just have to permute the letters to get for beta and alpha. But the law of cosines, if we remember what they are, we don't have to remember the specific cases because the formulas themselves tell us what we need. If we're trying to solve for an angle with the law of cosines, I want to know what gamma is. I need to know A, B, and C. A and B, I already got those. So I need to know A, B, and C. I need to know all 3 sides. The formulas themselves tell you what to use. So sometimes we look at the given information of A, B, and C, and then we go backwards to the law of cosines. But if we just have all these things programmed into our mind, these 3 different things programmed into our mind, we'll look at the given information and say, oh, we have all 3 sides. I remember the one with all 3 sides. That's solving for an angle. Then we just have to remember how to permute the A, B, and C to get gamma, beta, and alpha. So we can use the law of cosines to solve for an angle. We can also use the law of cosines to solve for a side. And the given information will tell us if it's going to work or not. If I have 2 sides, A and B, and the angle gamma, that's the angle between those 2 sides. Pardon me. Angle between those 2 sides. Then the law of cosines is going to work. So we have to identify that we have 2 sides and the included angle. We have to make sure everything's labeled properly. If we have 2 sides and the included angle, that's the angle in between, that's contained in those 2 sides, then we'll use the law of cosines and we can use that to solve for the 3rd side. So if we don't have all 3 sides and we don't have 2 sides in the included angle, that means we're down here in one of these other cases, in which case we can use the law of sines. So the law of sines is actually 3 different equations all combined into one equation. If we want to be sophisticated and fancy, we could say the law of sines states that the ratio of the sine of an angle to the side opposite that angle is constant in any triangle. Then we'll sound super fancy. But what it really just, as a formula, it's sine alpha over A equals sine beta over B equals sine gamma over C. Notice that if we have all 3 sides, then this isn't going to work because A, B, and C are spread out over 3 parts of my equation. And I need 3 things concentrated in 2. I need A, B, and alpha, or A, B, and beta to make the law of sines go. Also notice that if we have A, B, and gamma, we also can't make the law of sines go. If we have A, and then B, and then gamma, we have our information is spread out over 3 parts of this equation, and we need only 2 parts of the equation to make the equation go. So once we learn what the forms of the law of cosines and the law of sines are, we can take the given information, make sure it's sorted out correctly, and then we use whatever one we have, whatever one we can use. So let's talk about the law of sines. There are 2 cases where we have to use the law of sines to find our first piece of abundant information, for our 4th piece of information. We're given 3, we got to find 4, 5, and 6. There are 2 cases where we have to use the law of sines to find our 4th piece of information. If we have 2 angles and 1 side, that's the case for the law of sines. Sometimes these are listed twice. Angle, angle, side. This is 2 angles and 1 side and a side opposite one of those angles. And ASA for angle, side, angle. That would be 2 angles and the included side. But if we remember from solving right triangles, as soon as you have 2 angles, subtract to find the 3rd. So if you're given 2 angles, either angle, angle, side, or angle, side, angle, Subtract to find the third, and you have an abundance of information. Given two angles, subtract to find the third angle, because the sum of the angles in a triangle is 180. Alpha plus beta plus gamma is equal to 180 degrees. That's always the case. We don't get to use the Pythagorean theorem anymore because we have oblique triangles, but the sum of the angles in a triangle is always 180 degrees. The other case of the law of sines, so that would be if we have alpha, beta, and side A or side B. Two angles and the side opposite one of those angles. If we have alpha, beta, and side C, then we could subtract to find gamma, and then we have beta and gamma and C, then we can use this part of the law of sines. Or we can say we can use alpha and gamma and C, and use sine alpha over A equals sine gamma over C to solve for A. So two angles in one side, doesn't matter what the angles are, subtract to find the third, and you'll be able to use the law of sines. Awesome. We'll do an example in a minute. The other case where we have to use the law of sines is side-side angle. Notice that this is different than side angle side. Side angle side is two sides and the included angle. Side-side angle is two sides and the angle opposite one of those sides. So two sides, but the angle opposite one of those sides. That makes sense because if I have two sides, B and C, let's say, the angle opposite one of those sides will be beta or gamma. And so I'd have three pieces that I can use in the law of sines. If I have, say, B, C, and gamma, I can't use the law of cosines. I could use the law of cosines if I wanted to be all quadratic about things, but we want to avoid that. So let's just put a pin in that and move on. So if I have B, C, and gamma, that's a case for the law of sines. Because if I have gamma, I need A and B to use the law of cosines, because we have just one angle here. When we get to side-side angle, we want to recognize this is the ambiguous case. That means we could have 0, 1, 2, or 1 triangles. I know I listed 1 twice because there are two ways that we could end up with 1 triangle. But if we have two sides and the angle opposite one of those sides, we could end up with no triangles. We could end up with 2 triangles. And there are 2 different ways that we could end up with 1 triangle. This one in the middle is very specific. This one is more general. 2 different ways we can end up with 1 triangle. So that's an overview of the law of sines. Let's take a look at an example. Let's suppose I have alpha is 33 degrees. Let's suppose that beta is 97 degrees. And let's suppose that side C is 12 centimeters. So I have 2 angles and a side. In this case, we have 2 angles. As soon as we have 2 angles, we should subtract to find the third angle. So the first thing we need to go after is gamma. In this case, it's kind of the first thing that we have to go after because I don't have the right information for the law of cosines. Law of cosines is for 2 or 3 sides, and I only have 1 side. So this looks like a job for the law of sines. Since we're looking at 2 angles, 33 and 97, we're going to subtract to find the third angle. 180 minus 33 minus 97. So let's grab our calculating machine. I know I'm like, we should be able to just do this by looking at it, especially with the 7 and the 3. That's another 10. So 9, 10, 11, 12, 13. So it's going to be 50. Let's find out. I'm not very good at arithmetic. 50. Maybe I'm better at arithmetic than I thought. I'm going to put 50.0 to make it look like the other ones. Just kind of like make everything fit in. So I've got an angle, and now I have an abundance of information. And more importantly, I have C and gamma. So I have one fraction in the law of sines. Now I have C and gamma, we can use the law of sines. Because we have this fraction, alpha, sine gamma over C. So I'm going to use sine gamma over C. I got to find side A and side B. So I'm just going to set up a fraction. So I'll say sine gamma, 50 degrees, divided by C, 12 centimeters, is equal to the sine of alpha, 33 degrees, divided by side A. So here I'm solving for A first. So this means that A, if I want to solve for A, it's in the denominator, so I'm going to flip everything over and then just multiply. So A is equal to 12 times the sine of 33, and then divide by the sine of 50. Now I got something that I can just punch into my calculator. I'm going to first make sure that I'm in degree mode, and I am. And so A is going to be 12 times the sine of 33 divided by the sine of 50. So it looks like A is 8.53. I'm just going to write 8.5 since I said round to the nearest tenth on all the quizzes. I can do the same thing to solve for B. So let's make another fraction. I'm gonna use C and gamma. This A, I could say sine of 33 over 8.5, but this 8.5 has been rounded off. And this 50 we just got from subtraction, the 12 was given. So I'm going to continue to use C and gamma. So I'm going to say the sine of gamma, 50, divided by 12. And this way I'm going to use unrounded information. So this is equal to the sine of 97 divided by B. And we'll solve for B the same way we solve for A. B is going to be 12 times the sine of 97 this time, divided by the sine of 50. So I'm just going to do the same thing, but instead of 33, I've got 97. That's going to be 15.5. And that's it. Let's make sure that this fits our reality check. This is not a guarantee, but at least we know to rule things out. Is the biggest angle opposite the biggest side? The biggest angle is 97 and it's opposite the 15.5. So that checks. Is the smallest angle 8.5 opposite the 33 opposite the smallest side? 33 is opposite the 8.5, so that checks. The middle angle, that's the middle side. The middle side is opposite the middle angle, so at least this checks out. Any questions? The way that you want to think about solving oblique triangles is the biggest decision comes from how do you get that fourth piece of information? And then you want to try to default to use the law of sines whenever you can. The law of sines requires opposite information. Gamma and C, that's what a case to use the law of sines. If you're given two angles, you use subtraction to get that fourth piece of information. If you're given three sides, you use the angle form of the law of cosines to get that fourth piece of information. If you really dig the law of cosines, you could use it 3 times. But that's how you get that fourth piece of information. If you're given two sides and the included angle, you can use the law of sines, the side form, to get that fourth piece of information. Any questions? Great. Let's talk about side-side angle and why this is the ambiguous case. So side-side angle is the ambiguous case. What we mean when we say it's the ambiguous case, it could mean there's 0, 1, 2, or 1 triangles. The given information could lead 0, 1, 2, or 1 triangles. I know I said 1 twice, and I know I said it but I said it in this very specific order. 0, 1, 2, or 1 triangles. So we're given two sides and the angle opposite one of those sides. So we're given two sides and the angle opposite one of those sides. So let's draw, let's see. I'm going to look at the triangle that I used on the quiz. I think this is not normally how I draw it, but that's okay. So for example, so this is two sides and the included angle, or sorry, two sides and the angle opposite one of the given sides. The two sides take different roles. This is not like side angle side, where it's two sides and the included angle. This is two sides and the angle opposite one of the given sides. So I'm going to name the two sides. I'm going to say one of the sides is the side opposite the given angle. One of the sides is the side opposite the given angle, and then we have the other given side. So we don't just want to say the side, because we need to distinguish the two. They take different roles. One is the side opposite the given angle. The other one is the other given side. So for example, a set of information might look like, I might be given sides A and B and angle alpha. So I have A and B and the angle alpha. A is going to be the side opposite the given angle, and B will be called the other given side. So A is the side opposite the given angle, and B I will refer to as the other given side. Alpha is the given angle. Let's draw a picture of where things are going. I need a baseline. This is where the third side is going to go. So this is the line that the third side will go. I'm going to draw the angle alpha is going to be between side C. So in this case, it'll be where side C goes. So somewhere along here is side C. I'm going to draw side B connected to side C. So that's the other given side. And alpha is going to be the angle between side B and side C. We don't know what side, how big side C is going to be. But alpha is going to be opposite side A. So side A connects this end of side B to side C. So now we can see how we're going to get 0, 1, 2, or 1 triangles. If side A is too short, then I won't be able to connect to side C without shrinking alpha, and that we can't do that. If side A is too short, then we get 0 triangles. If side A is too short, then we get 0 triangles. That's the first thing. If side A is too short, then we get 0 triangles. If side A is exactly long enough, if we go perpendicular to side C, then we'll get exactly 1 triangle. If side A is perpendicular to C, then we get exactly 1 triangle. And that means that side A will actually be the height of the triangle, and you can use C as a base. If side A is exactly the height of the triangle, then we get 1 triangle. We had a right triangle and we didn't know it. Then we get 1 right triangle. So we could see if we draw A from this end of B straight down to C, perpendicular to the line where we're going to find C, then we'll have exactly 1 triangle. If side A is a little bit longer than the height, but shorter than the other given side, the wording is getting a little little messy here. If side A is greater than the height, so side A is greater than the height, but less than the other given side, then we'll have two triangles. In this case, side B is the other given side. If side A is greater than the height, but less than the other given side, that's side B, then we get two triangles. Because what we can do is if we drop the height down from side A to side C, if I make side A, the side opposite the given angle, a little bit more than the height, then I can draw two triangles. One over here, and one over here on the other side. And I can just imagine swinging a compass between those two. So that's what the two triangles case would look like. So that means we have two triangles that we have to solve. Now, we only get these two triangles until A gets to the same length as B, in which case we stop getting this triangle on this side, because if A would just have, if the side opposite the given angle is equal to the other given side, then this triangle drops out. But we can always go to the, just make C longer, no matter how big A is. So how do we summarize that? If the side opposite the given angle, if side A is greater than the other given side, I just realized I mixed side A and other given, oh, it's okay. If side A is greater than side B, then we get one triangle again. So this is how this set of given information is ambiguous. If you have two sides and the angle opposite one of those sides, then you could end up with 0, 1, 2, or 1 triangles. If the side opposite the given angle is less than the height, you get no triangles. If the side opposite the given angle is equal to the height, you get one right triangle. Magic case, that's the hole in one. If the side opposite the given angle is greater than the height, but less than the other given side, then we'll get two triangles. If the side opposite the given angle is greater than the other given side, then we get one triangle again. Now, this sounds like a mess. Here's the good news. We don't have to classify this right away. We just have to be aware that this could happen. The numbers will work themselves out. We just have to be prepared that side-side angle could give us two triangles and be ready for that to happen. We don't have to know before we start making calculations. We just say, oh, it's side-side angle. Could be 0, 1, 2, or 1. Let's see what the numbers tell us. Be aware that the ambiguous case exists. And just remember that when you make your calculations. Any questions? I see a picture of two dogs. Someone's using a picture of their two dogs. Are there, if those are both corgis? They look like they're both corgis.
Yeah, they're both corgis.
They are super cute.
Thank you.
All right. Next time on Wednesday, we'll talk about the ambiguous case. We'll look at all four of these cases, and we'll see how we can determine what's going to happen. So we'll make sure everything fits together. We'll see how the numbers show us what case we're in. So that all we have to remember is that side-side angle. We're going to use the law of sines for the fourth piece of information, and we have an angle and a side opposite that angle. We have to be aware that it could be 0, 1, 2, or 1 triangles. The numbers will tell us which case we're in. All right, that's it for today. I will see y'all on Wednesday. Everybody have a good day, and thanks for playing.